Hi and welcome to Chemistry Video 1.2, Separating Mixtures. By the end of this video, you should be able to separate mixtures using decantation, filtration, chromatography, and distillation. So there are many ways to separate a mixture. Most of the time, if it's a heterogeneous mixture, you can just pull it apart like this. However, if this is one of those times where you can't do that, then use the following methods below. The first one is decantation. Then we have filtration. Lastly, we have distillation. So let's talk about decantation first. Decantation is probably the most simplest way to separate a mixture. In fact, it is the quickest way. But there are some drawbacks to that. The first one being that, one, it requires a heterogeneous mixture to separate. Next, if you look at solution beaker A, right over here, you'll see that the objective is to slowly decant all of this liquid out of it into beaker B. The problem arises when you're low on liquid and some of the solid particles begin to separate into beaker B as well. Now, if this happens, well then you got to restart. Now, say that you didn't even pour that much to begin with. Well, if that's the case, then you're probably stuck with a lot of liquid still in beaker A. So those are just some of the drawbacks. But the really cool thing about decantation, though, is that you actually use it in everyday life. For instance, if you went to the beach, you're probably one of those people that are building sandcastles. And if you are, you probably know the real struggle where you go in and you just take a bucket full of sand and then you're stuck with a lot of water on top. So what do? Well, you slowly decant that water off and try and get stuck with just the sand itself. Next, we have filtration. Filtration is a little bit more accurate than decantation, but there are some drawbacks to this as well. For instance, it does require that you need to have a heterogeneous mixture. But let's dive more into this. As you can see here, we have a filter paper inside of a funnel. The objective here is to take our heterogeneous mixture, and I know this is heterogeneous because, well, there's solid particles and liquid. So because I can see that separation, I know this has to be heterogeneous. Anyway, what I do is I slowly pour this liquid into the filter paper, and the filter paper is supposed to stop the solid particles from going through into the beaker. Now, if you've successfully done this, then you filtered it all out. But most of the time, we see that some of those solid particles, if they're small enough, they crack through that little opening there and fall in as well. If this happens, then once again, you have to restart your whole system. So this isn't ideal. Next, we have distillation. And what's really cool about distillation is that this can separate homogeneous mixtures. So let's go ahead and dive deeper into this one. So let's say that we have a homogeneous mixture here, and we have substance A and substance B. Substance A has a lower boiling point than substance B. So what this means is that because this is being heated up, we start to see substance A turns into a gas first. And once it turns into a gas, it then goes through this condenser phase, and this condenser phase begins to cool it. Once it's cooled, it turns back into a liquid. Now what's really cool is that when you come back over here, we have substance B still here in its liquid form. While it's in its liquid form, you can then remove this or turn off the Bunsen burner and you should be done. Now the drawback to this though is that let's just say that you're not closely monitoring this thermometer. Well, once this reaches its boiling point as well, this will then turn to a gas and then this move back into this Erlenmeyer flask over here. Now if this happens, well now you just moved both solutions into this Erlenmeyer flask and then you're back to step one. So that's the problem. So just make sure that you're closely monitoring this thermometer over here, or you remove this Erlenmeyer flask so that you don't have that situation. Now just to recap, lower boiling points boils first, then it turns into a gas and goes through a condenser, and then it becomes a liquid again. Now this is actually how many companies clean water. Lastly, we got chromatography. Now what's really cool about chromatography is that this isn't really used to separate mixtures at all. Instead, we use chromatography to show the separation of mixtures occurring. So the way that it works is we're going to take 3 different small samples and pour it onto some chromatography paper. As you can see, I've marked red, blue, and black. Now once you have your small sample on your chromatography paper, go ahead and insert it into your column. Once it's inside of the column, you should have some liquid here. This liquid is what causes the sample to start showing its separation. As you can see, once you've taken it out over here, we move on to 2 parts of red. Red is simply 2 parts, 1 part red, 1 part yellow. Blue is simply 2 parts as well. It's 1 part blue and 1 part, it looks like it's yellow. Next we have black. Black is 3 parts. It's 1 part red, 1 part green, and 1 part purple. So remember, this method is usually used to determine if the sample is pure or not. It is not used to separate a mixture. Now, if it is not a mixture, then no separation occurs. So don't let that be a trick question for you. Lastly, let's go ahead and show you guys how they're going to ask you the chromatography questions. So you're going to be given a picture. Or in the lab, you're going to have to identify 2 of the known substances or 2 of the same substances. Now, when that's the case, all you got to do is find the pattern. For instance, as I look across the chromatography paper, I'll notice that I and II contain the same exact separations. Because of this, I know that I and II must in fact be the same I could then go ahead and make the same assumption for C and IV. As you can see, it's two parts, one part purple, one part pink. And because of that, I could also make the assumption that C and IV are in fact the same substances. Lastly, I want to end with the chromatography joke of the day. So let's go ahead and say that Timmy decides to go to Whataburger. And once at Whataburger, he happens to spill a small sample of his burger on top of his shirt. His best buddy George says, hey, why don't we take that shirt sample and put it on some chromatography paper? When they go ahead and do that, they notice that the burger separates into 5 different sections. The first part is just the bun. The bottom part is a bun as well. And then right on top of the bottom part, we have some meat, followed by the pickle. Yet that second layer, we see that it's actually employee's spit. Now, just so you know, that's just a joke, and I really love Whataburger, so hopefully you guys don't take that seriously. Well, that's all I got for you guys today. Hopefully you enjoyed. We'll see you guys in chemistry video 1.3. Thank you.